Okay, for question A, they ask you to find f of 0 and f of 5. So what you do is you use the fundamental theorem of calculus and move the variables around, like you can see here. This is for f of 0. And you plug in f of 4 for 3 because it gives you the value in the question. And for the integral, you can use geometry like this here. Integral of f of f prime from 0 to 4 is from here to here, which is a semicircle with radius 2 and under the x-axis. So here is negative 2 pi, and minus negative 2 pi would be plus 2 pi. And you could do a similar process for f of 5. And for B, to find the inflection points, you see where the f prime graph changes from increasing to decreasing, and those points are at x equals 2 and x equals 6 on the graph. And for C, to show when g is decreasing, you basically just take the derivative of g and then set up an inequality to find when it's less than 0. And what you get is f prime is less than 1, which is true in the case of x equals 0 to x equals 5. That's the interval right there. And then for D, to find the absolute minimum, you just use the candidates test. So you find critical points of g, which is the derivative when the derivative is equal to 0, like the equation set up here. And what you get is x equals 5. And the other candidates are the endpoints, which is 0 and 7. So you see in this table, we have 0, 5, and 7, and the y values respectively. And the absolute minimum is the lowest y value, which is negative 1.5.